Welcome to your Algebra 2, Lesson 8.2. Today we're going to graph simple rational functions. So our whole objective today is that you can graph at least the simple rational functions. So what is a rational function? Well, a function of the form f of x equals p of x over q of x, where p of x and q of x are polynomials and q of x aren't equal 0, is a rational function. So let's talk about that. So you're going to have one polynomial divided by another polynomial, and they're going to be in terms of the same variable. They're both going to be in terms of x per se. Why q of x not equal to 0? Because we can't divide by 0. So we have to exclude that. All right, so as always, when we start talking about functions, we start talking about parent functions. Now, a parent function for a very, very simple rational function is f of x equals 1 over x. The graph of the parent function f of x equals 1 over x, and I have a picture of it right here, is a hyperbola, which consists of two symmetrical parts called branches. So here's one branch right here, and here's the other branch. The domain and range are all non-zero real numbers. So x can't equal 0. Okay, if you look right here, there's no y value defined for x equals 0, and y can't equal 0. This branch approaches y equals 0 from above. This branch approaches y equals 0 from below, but it never equals 0. So these little branches never actually cross the x-axis. The asymptotes are the vertical line x equals 0 and the horizontal line y equals 0. Any function of the form g of x equals a over x, where a is not equal to 0, because that would just give us g of x equals 0, has the same asymptotes, domain, and range. So as long as we don't add or subtract anything anywhere, we just have g of x equals a over x, so 2 over x, negative 2 over x, 3 over x, anything like that, the asymptotes are going to be at x equals 0 and y equals 0, and the domain and range are both going to be all non-zero real numbers. Okay? Okay, so we're going to graph a rational function of that form. So we're going to graph the function y equals 6 over x, and we're going to compare the graph with the graph of y equals 1 over x. All right, so to graph these, the first thing you do is you draw in your asymptotes x equals 0 and y equals 0. So you dot in a vertical line at x equals 0 and a horizontal line at y equals 0. Step 2 is you plot the points to the left and to the right of the vertical asymptotes. Okay, so you want to pick some x values that are smaller than 0 because the vertical asymptote is at x equals 0, and some x values that are larger than 0. So here you can see they picked negative 3 and negative 2 for the less than 0, 2 and 3 for the greater than 0. You can feel free to create a table when finding these points. It's kind of what we've been doing. So if you want to make a little rectangular table where you have your x values and then generate your y values, you just pick some to the left of 0 and some to the right of 0. I'm not quite sure why they didn't pick negative 1 for an x value also and positive 1. I would have, but this is what they did. All right, so what you do then is you plot those points and you draw in your function. Now we don't have to put in the parent function if we're just graphing y equals 6 over x. We don't have to do that this time. They went ahead and put that in because we're going to make a comparison. Okay, we're going to compare the two. So that's the only reason to worry about putting the parent function in. You don't have to do that this time because it's really easy just to go ahead and generate the correct y values. Okay, draw the branches of the hyperbola so that they pass through the plotted points and approach the asymptotes. So that's what our little picture right here did. Okay, so we've gone through the points and they're approaching the asymptotes. It's going to take a little while, so it's just getting closer and closer to our dotted in asymptotes. Down here they did the same thing. So now we're going to make the comparison because we've got the graph. The graph of y equals 6 over x lies farther from the axes than the graph y equals 1 over x. And both graphs lie in the first and third quadrants and have the same asymptotes, domain, and range. So that's the only kind of comparison you would need to make. All right, now that y equals a over x, it's the simplest form. There's been no translations. And we know any function can be slid to the left and the right or up or down. And so our good friends h and k are going to come back into play. To graph the irrational function of the form y equals a over x minus h plus k, notice once again it's x minus h and then plus k. So that means when you're determining h, you have to think a little harder than when you're determining k. You want to follow these steps. Step 1, you're going to draw the asymptotes. Your vertical asymptote will be at x equals h, and your horizontal asymptote will be at y equals k. Plot points to the left and to the right of the vertical asymptote, okay, to the left and right of x equals h. Remember, you can make a table for these, and I suggest you do that because it's familiar for us. Step 3, draw the two branches of the hyperbola so that they pass through the plotted points and approach the asymptotes. Okay, so let's look at a problem like this. So we're going to graph y equals -4 over x plus 2 minus 1, and we're going to state the domain and range. Okay, so the first thing we do is draw in the asymptotes at x equals h and y equals k. Because we have x plus 2, we need to think of that as x minus -2. So our vertical asymptote is going to be at x equals -2. And then k is -1, and so y equals -1 is going to give us our horizontal asymptote. All right, and they have it drawn in here, and they didn't use dotted lines, but remember for the asymptotes, I like for you to use dotted lines to help you remember that those are the asymptotes. So dot in a vertical line at x equals -2. So instead of a solid red line, we're just going to have a dotted line. And then a dotted horizontal line at y equals -1. And remember, these provide like guidelines. We're going to make sure our branches approach them. Plot points to the left of the vertical asymptote, such as -3, 3, and -4, 1. Okay, again, I think making a table might be helpful for you. And so you just look and you go, okay, -2 is my value for h. Pick at least two values smaller to the left of -2. So x equals -3, x equals -4 certainly works. You plug those in and you generate your y values. So -3 plus 2 is -1. 4 divided by -4 divided by -1 is 4, minus 1 is 3. So they're just generating the y values like we always do. Okay, and then pick a couple of points to the right of -2. So x equals -1, x equals 0 certainly works. And then you generate your y values. So you plug in those x values. So let's do 0 because that's going to be easy. 0 plus 2 is 2. -4 divided by 2 is -2, minus 1 is -3. So generating these ordered pairs very much like what we've done before. Okay, once you have them, you plot them, and you draw in the piece that's to the left of your vertical asymptote, and then you draw in your piece that's to the right of the vertical asymptote. Notice you don't try to connect all the points. That's not the goal. You know you're going to have two pieces, and you have to bring that knowledge to graphing this. And so you go through the points that are in the same area, to the left of the vertical asymptote or to the right of the vertical asymptote, and you draw in a smooth curve that approaches the horizontal asymptote and approaches the vertical asymptote. Okay, notice that we're in different quadrants this time. Well, primarily in different quadrants. Of course, because of the sliding, there's some crossover, but relative to our vertical and horizontal asymptotes, we're in different quadrants than we were before, and that's because A is negative. Okay. Step 3, draw the two branches. We just talked about that of the hyperbola so that they pass through the plotted points and approach the asymptotes. Okay, so the domain is going to be all real numbers except -2, so all real numbers except h, and the range is all real numbers except k, so all real numbers except -1. Now, today we're going to cover one more form, and those are rational functions of the form y equals ax plus b over cx plus d. So you've got coefficients in front of x's on top and bottom, and you're adding things in the numerator and the denominator. Okay, these have graphs that are hyperbolas, so we've got our two branches, have a vertical asymptote at the x value that makes the denominator equal to 0. So we're going to take cx plus d and set it equal to 0, and that's going to give us our vertical asymptote. And then have a horizontal asymptote at y equals a over c. So if you look, you just do the ratio of the coefficients of x, and that's going to give you your horizontal asymptote. So let's graph one that's in that form. Okay, so we've got y equals 2x plus 1 divided by x minus 3. We're going to state the domain and range. Okay, so first thing we do is draw the asymptote. So we're going to solve the denominator equal to 0, so x minus 3 equals 0, for x to find the vertical asymptote x equals 3. Okay, the horizontal asymptote is the line y equals a over c. So a is 2, c is 1, and so it's 2 over 1, which is 2. So drawing a dotted line at x equals 3. Okay, now it may look a little weird because this graph has been scaled by 2's, so x equals 3 is in between 2 and 4, obviously. And then y equals 2 is on the first little tick mark on the y-axis because it's counting by 2's. So draw in a horizontal line dashed in there. Okay. All right. So what have we been doing after that? We've been picking x values that are to the left of our vertical asymptote and x values that are to the right of our vertical asymptote and generating values. I prefer a table of values. The authors of your book did a list. So I've gone ahead and pasted another copy of the graph on this slide so that we can look at it. So we're going to plot points to the left of the vertical asymptote. So we pick things like 2 and 0 for those x values because they are to the left of x equals 3. And we generate y values of -5 and -1/3. We plot those, and then we pick points to the right, so like 4 and 6, and we generate y values. And again, create a table if that helps. Step 3, you're going to draw the two branches of the hyperbola so that they pass through the plotted points and approach the asymptotes. So the domain is all real numbers except 3. Okay, but why except 3? Because that's where our vertical asymptote is. And remember, that makes our denominator equal to 0. So we got to kick it out. And the range is all real numbers except 2 because that is our horizontal asymptote. This branch approaches 2 from above. This branch approaches 2 from below, but they never cross that horizontal asymptote. Okay, they just approach it. So make sure you draw your graph accordingly where the branches approach it but don't cross it. Okay, guys, that's it for this video. Sorry if my neighbor's dog has bothered you, but I will see you in class soon. Do those problems to try on your own and be ready to go over them and do your rounds. Thank you. Have a good day.